All right, we are extending our learning of absolute value, and we're moving to learn about we learned about absolute value equations, and now let's talk about absolute value inequalities. Remember, greater than, less than, greater than or equal to, or less than or equal to. So steps for solving those inequalities are the same as equations, except you'll have some inequality signs. So when you change the answer to a negative, you're going to flip the inequality sign when you change the integer. So let's look at an example. We'll go through these together. So first we want to isolate our absolute value bars, which here they're already isolated, so that's good. And now we're going to write our two equations. One is going to be for a positive, one is for a negative. So notice here we have x minus 5 is less than 2, or x minus 5 is greater than negative 2. So see how we switched the inequality sign here when we negated the integer. All right, so solving, both sides will add 5, and then we have x is less than 7 and x is greater than 3. Added step here, this is how you write it. X is greater than 3 and x is less than 7, where your smaller number goes first and then your larger number is on the other side, on the right side. Your added step here is graph. So here is our graph. This is what this looks like. This is called, this inequality, I'm looking for my pen to write it down for us, is called a conjunction. See how they go together? Con means with, right? So this is a conjunction. Put in the box, where you think of it as an and. X is greater than 3 and x is less than 7. It's a conjunction. Let's look at another example. We have the absolute value of 3x minus 4 is less than or equal to 5. Our absolute value bars are already isolated, so we can go ahead and write our two equations. We have 3x minus 4 is greater than or equal to 5, and it's 3x minus 4 is less than or equal to negative 5. So you're switching the inequality and you're switching the sign here. Solve by adding 4 on both sides of your inequality. And then we have 3x is greater than or equal to 9. Here we have 3x is less than or equal to negative 1. Divide by 3, and here's our solutions though. So notice that x is greater than 3 and x is less than or equal to negative 1/3. So this is called a disjunction. It's disjunctive because they go away from each other. So take a look at what it looks like on the graph down here. They're going away from each other. So notice the difference. This is a conjunction. This is a disjunction. Dis meaning away, right? Or opposite. So let's try some of these examples. I'm going to put these up. Let you give them a whirl. So I'll leave this here for you. That doesn't need to be there. And then I'll put up the answers. So pause the video, try one, and then come back. All right, so this first one, absolute value of 2x plus 1 is less than 3. My absolute value bars are already isolated, so we're going to write our two equations. 2x plus 1 is less than 3, and 2x plus 1 is greater than negative 3. I'm going to solve the one on the left first by subtracting 1. And then dividing by 2, so x is less than 1. And then here we'll solve it the same way. Divide by 2, x is greater than negative 2. So we have x is less than 1 and x is greater than negative 2. Before I write it out, let's just see what it looks like on the graph if it goes together or if it goes opposite. So we have negative 2 here and 1. My circles are open, and now x is less than 1 goes this way and greater than 2 goes this way. So they meet in the middle. So this one is our conjunction. So we're going to write it as x is greater than negative 2 and less than 1, right? Interval notation, we can write it like this, -2 and 1, like that. Both of those are correct. The correct way to write your solution, interval notation, inequality notation. All right, let's try number 2. We have 2 times the absolute value of x plus 4 is greater than 8. I need to isolate my absolute value bars first, so we're going to divide by 2. So we have the absolute value of x plus 4 is greater than 4. So we have x plus 4 is greater than 4, and x plus 4 is less than -4. We'll solve by subtracting 4. So x is greater than 0. Subtract 4 here, and x is less than -8. So let's see on the graph what kind of solution we have. We have a conjunction or a disjunction. So there's 0, 3, 4. Almost didn't make it there. So if x is greater than 0, coloring away or shading away, right? X is less than 8, shading away. So it's a disjunction. So we're going to say, like our example on the last one, with that union sign, right? Because they go to negative infinity. So you can write it like this: x is less than -8. And with that union sign, x is greater than 0. Here it is as an inequality or an interval with negative infinity to -8, both parentheses, and then 0 to positive infinity. So that's how we would write it with the interval. All right, number 3, let's look at that one. Number 3 says the absolute value of 12x plus 5 minus 2 is greater than or equal to 7. We have to add our 2, get rid of that 2 first to isolate our absolute value bars. Oh, that's supposed to be 2, isn't it? 9, how about a 9? 12x plus 5 is greater than or equal to 9, and 12x plus 5 is less than or equal to -9, right? Flip the inequality sign, flip the integer sign. We'll solve this by subtracting by 5. So we have 12x is greater than or equal to 4. Divide by 12, and x is greater than or equal to 1/3. Look at it here. Subtract 5. 12x is less than or equal to -14. Divide by 12. And x is less than or equal to negative, let's say 7/6 as we reduce. Okay, so let's graph it to see how we would write these solutions here. I have 0, I have a -7/6 and a positive 1/3. So if x is greater than or equal to, gonna shade in, x is less than this and greater than our 1/3. So it's going to be that union together with it. And then interval notation, we're going to say negative infinity to -7/6 with a bracket. And then that union sign bracket here, 1/3 to positive infinity with a parenthesis. So that's our interval notation. All right, I'm just going to go ahead and show you the solutions for the last 2. All right, here's our solution for number 4. They're a disjunction here. And then our solution for number 5 took a little bit of work on the front end to isolate those absolute value bars. And then it's also a disjunction. So try those again, or go ahead and move on to your practice for the day.